Getting feedback from your users of your apps is critical, particularly if they've encountered a bug. Hi, my name's Stewart Lynch, and in this tutorial, we're going to be looking at adding the ability to include an email support button in a SwiftUI app. We'll be exploring two options, both of which provide critical application information in the body of the message to help you know more about the user sending them email. In the first case, we'll use the OpenURLaction, and in the second, a UIViewControllerRepresentable to present the MFMailComposeViewController. Both have advantages and disadvantages. The OpenURLaction is easy to implement, but it uses the default mail app to send the email, which takes your users out of your app and doesn't give you the ability to add any attachments. The second option is a bit more difficult to implement, but you never leave your application, and if you want, you can create a JSON representation of the user's data and include it as an attachment to the email. As mentioned, both emails contain important information about the user's device, iOS version, and your app's version to assist you with their request. This video is sponsored by Stream. Stream Chat is the easiest way to add messaging to your iOS apps. The high-level components connect the Stream API with minimal coding, and you can get a free version of the Stream API with full feature access for personal projects and qualifying small startups. This makes it perfect for those side projects. You really need to check this out. Use the link in the description below to apply now for your full and free access to Stream's chat and activity feed APIs. No credit card is required. Make sure if you like this video to give it a thumbs up and subscribe to my channel. Also, ring the bell to make sure you get notified of new videos. Also, feel free to leave a comment below, and if you want to support my work, you can buy me a coffee. There is a starter project for this tutorial, and you can download it from the link in the description below. There's a sample app called Team Sports, and another folder for additional resources that we'll be adding to the project. Open the project, and on the content view, you'll see that the list of Team Sports is being displayed along with a toolbar button that says Email Support. The button's not wired up yet, but the list is derived from the example data model, and it's an identifiable object with a static array called examples. That's an array of these example data. We'll go over these two extensions in just a minute. For the launch screen, I've created a launch screen using a storyboard because I'm annoyed with the bug in SwiftUI where the image sometimes expands to cover the entire screen. So when I create the app, I specified that the launch screen storyboard will be used for the storyboard. And the assets contain the app icon and the image used for the launch screen. In the Team Sports app file, I have an onAppear function that solves another annoying bug that if you're using a navigation view and a list in SwiftUI, all sorts of constraint errors get printed to the console, and I find that distracting. So this disables that. Now before we start adding our email functionality, I want to gather information that I can place in the body of my email automatically, so that when users send the email, it will contain some information that will help me determine what might be causing any issues identified. There are 5 things that I want to include, and that's the iOS version, the device model, the app name, version, and app build. Getting the iOS version is the easiest, and this can be found from the UI device class, which is a representation of the current device. In the Team Sports app Swift file where the content view is presented, and within the onAppear block, let's explore this a little. We'll start by typing uidevice.current, and a lot of options will appear. If you select .system version, you can print it out, and let's run the app on a simulator. You'll see that the current iOS version appears. Perfect. That's the first thing that I'll need to know. What about the device model? If I print the uidevice.current.model and I run the app once more, Unfortunately, this isn't very helpful. It doesn't indicate what actual model we're on, only that we're on an iPhone. So let me try UIDevice.current.name instead. Well, this looks great. It looks like what I want, but it's actually an editable field that you can find on the General tab of your device. It's not editable on the simulator, and it does give the correct model name here, but there are no guarantees that the user hasn't changed this to something else. In fact, it's encouraged, as that's what will be displayed when you do an airdrop. Now there's another more obscure setting that can help us out though. And this is what this code snippet I've provided in the extension folder is for. So let's uncomment this out right now in the UI device extension. And I'm going to return to the print statement. And this time, instead of printing out the current name, I'll print out the current model name. When we run our app, I get iPhone 14,2. And that's the official iPhone model code. And that code snippet will display the correct code whether you are on a real device or in the simulator. So now all we need to do is to match all of these codes that there might be for all of the different devices, both iPhone and iPad, and display the friendly name instead so that when you receive the email, you're not trying to figure that out. And there are a number of solutions that you can find on the internet. But I thought that I would use what I'm going to share here as something that you can maintain yourself. Now I found this just by Adam Wolf on GitHub. And it's right up to date, right up to and including iPhone 13, which is where we are at this time that I've created the video. Now, I converted this list to a JSON file, and you can find that in your resources folder. So drag and drop that into your project, and let's see how we can use it. In the UI device extension file, I'm going to create a new struct within the body of the extension, and I'm going to call it device model. And I'm going to have it conform to the decodable protocol. I'm going to create two string constant properties with the same names as the two keys that are in that JSON file, identifier and model. And now we can create a static property called all that will return an array of these device models. So I'll need to try to decode that JSON into an array. And I have that bundle extension here that will do that for me. All I have to do is call bundle.main decode, and we'll decode into an array of device model.self to indicate it's the type from the file, which is devicemodels.json. And now that we have that, we can replace identifier with the first model where the identifier matches one from the all devices. And if it can't find a match, we'll just return the identifier. If we run the app once more, we get the actual model. And that will work both for the simulator and for a real device. The other advantage is if Apple releases new devices, you'll have the simulators in Xcode so that when you run the app, it won't find a match, but it will print out the identifier so you can simply update your JSON for your next release. In the meantime, if your users have a new iPhone, you'll get the machine ID for those new phones. If I hook up my iPhone right now and run it, we'll see what I get. And you see I have an iPhone 13 Pro. Now the remaining three items that I want to gather are all part of your bundle. And these are what are displayed on the General tab of your target. And the ones I want are display name, version, and the build. These items are reflected in the Info.plist, which in the latest version of Xcode is displayed as a tab. And the ones that I want are bundle name, bundle version, and bundle version short. Unfortunately, these are friendly names, and they're not much good to us. We need to know what the actual info dictionary keys are. So I found this document on the internet, It's very helpful. On page 22, if we get down here into the Core Foundation bundles names, you'll get the Xcode name and the actual Core Foundation key, which is what we need. So the ones we need are CF bundle name, CF bundle short version string, which is the actual app version, and then further down the CF bundle version, which is the build version number. We can create a computed property then called displayName as a string, and then return the object for info dictionary key, and then use CF bundle name and return it as a string. But it's an optional string. So we'll get an error because it is optional. So instead of force unwrapping, let's just return a string such as could not determine the application name. Well, I can repeat then this for the other two. And all I'll have to do is change our variable and our info dictionary key to the corresponding key. So for app build, we'll use the CF bundle version. And for app version, it'll be the CF bundle short version string. And of course, I'm going to have to update those alternate strings in case for some reason it fails. So let's return now to our onAppear function and print all of these items out. This time when I run the app, we now get all of that information printed to the console. Perfect. Now we can start to code our email portion. We're going to be creating a struct for our email so that we can create an email object and use it to send the email. So what do we need? Well, first, inside the models folder, I'll create a new file and I'll call it support email. And inside that file, I'll create a struct of the same name. Now, every email needs a to address and a subject and body. So first we'll create two properties, one for to address and the other for subject. Both are strings. Now I might want to use this struct for multiple purposes, like for asking for a feature request or for submitting a bug. So in addition to changing the subject, it'd be nice to offer some extra information as a header. So I'm going to call this message header, which will be a string as well. Now for the body, I'm going to initiate the email with the information that we just found out how to retrieve. So we can use a computed property here and use the multi-line feature of strings to separate each item with a return. We'll start with a string like application name, and then follow it using the string interpolation to present those strings that we printed to the console. And the first one I want is application name. And for that, we'll use the bundle.main.displayName. Next, we'll present the iOS version. This will, though, require the import of UIKit instead of Foundation. UIDevice.current.system version. We'll follow that with device model. And here it's our UIDevice.current.model name, that new computed property. And then the app version, which is the bundle.main.app version. And then finally the app build, which is the bundle.main.app build. So once we've presented those pieces of information, we can include our message header. And then to separate the header piece here from what the user is going to enter, we'll just enter a bunch of dashed lines. Now, iOS 14 introduced the OpenURL functionality for opening a URL. And an email is simply a mail to URL. It's a form of URL that starts with mail to : If you check the documentation here, you'll see that the environment offers a handler that you can use with this. So we're going to use this environment variable here, OpenURL. So let's copy it and go to our content view, and the environment value can be placed at the top, and it will create that environment variable for OpenURL that will provide us with that handler. So in our button then, we can call this handler whenever we tap the button. But this requires us to form the URL first. So rather than doing this here in the view, I want it to be reusable. So I'll be passing this OpenURLaction variable to our struct so that we'll be able to keep the code out of our view. So the function will be a function of our instance of support email. So the first thing that I'll need to do in this view is to create an instance of that. So we'll create it as a private property at the top of our struct. For the to address, I'll enter my address, but you should enter your own email address, obviously. For the subject, I'll just type the string support email. And for the message header, I'll say something like, please describe your issue below. So in the support email struct now, we can create that function, and we'll call it send. And as I said, it will have one parameter, OpenURL, that will be our OpenURLaction. I'll call the string that we'll use to form our URL as URL string, and I'll format it as a mail to URL using our to, subject, and body. So we'll start with the let URL string equals mail to : and then use string interpolation to add the address. Well, this is followed by the subject and body as query strings. So for the first query string, we'll add question mark and follow that with subject equals, and again use string interpolation to present the subject, and then and body equals, using string interpolation following that for the body. Now this is all good, except when special characters and spaces are used in the subject and the body. So we can fix that by calling the add %encoding function to our string, with the allowed characters being URL path allowed. Now this is optional, and we can't have it optional, so if it fails, we'll just return an empty string. And of course, we'll have to do the same thing for the body. Well, we can now use a guard statement then to check if it's a valid URL, else I'll just return. Now, if we were to execute the OpenURL handler passing in this URL on a simulator, it would fail because the simulator doesn't support email. However, on the device it would work and the email will be sent. So if we want to test this out on our simulator, at least to see if we're getting a formatted body, we'll first have to determine whether or not that OpenURL handler passes or fails. And there are two versions, one that just accepts the URL, but the other one that has a completion handler. And that's a Boolean value, and that'll let us know whether it's been accepted or not. So let's use that one. Within the body then, we'll just check that if it's not accepted, we can print out a statement indicating that, followed by the body. Back in Content View then, we have to make sure then that we tap on our button. It's going to call the send function from our email instant, passing in that OpenURL. If I run on the simulator, the email doesn't get sent because it wasn't accepted, but it does print out the body. Let me connect my iPhone now and run it. This time the message is created, and you can see that it's addressed properly with the specified subject and body. All I'd need to do as a user would be describe the issue as requested and send it. Now that may be all you want to do for your email, and this is fine. However, in many of my apps, I like to get relevant parts of the data set so that I can do more debugging on my end. And I do this by means of serializing the user's data as JSON, ignoring any images, and recreating it in my own environment. And this means that I need to be able to attach the data to a message, and unfortunately the OpenURL handler doesn't allow us to do this. So we'll have to revert to an alternative that uses the MFMailComposeViewController, and that is available to us in UIKit, but not in SwiftUI. However, we can use a UIViewControllerRepresentable. Now, the purpose of this video isn't to show you how to create UIViewControllerRepresentables, and if you're interested in that, you can watch this video of mine that I created some time ago. Instead, I'm going to rely on the good work of others, and for this, I found this post on the SwiftUI recipes site. It has the 4 different components that are exactly what I'm looking for. I need to be able to determine whether or not I can send a mail or not. I can pass in the subject, the message recipients to the view via a binding. And that's what my email struct is going to be. And I can attach files to the email. And then I'll receive either a success or failure result after sending the email. Now, it is available as a Swift package, and you can check that out. But rather than importing a package, I've taken this code here and modified it slightly to meet our specific purposes. And it's available in the resources provided. So first, create a new group and call it UIViewControllerRepresentable. Then return to your Finder and open that additional resources folder and the UIControllerRepresentable folder and drag that mailview.swift file into the new group. That's exactly what we saw in that post with some modifications. The one assumption is that you have named your support email struct exactly the same way as support email. Now, I don't want to go through this code, and I don't really have to. I'll just show you how to implement it. So it is reusable. Now the first thing I'm going to do is add an optional property to our support email called data, and it's an optional data type. And since it's optional, our property in Content View where we instantiate that email, it doesn't break. But if we want to attach data to our instance, then we can do that after the fact, as you'll see here. Well, what is that data and what you want to be able to send along with the email? Well, in my case, in this particular application, it'll be the JSON representation of this array of data that we have in our example data. And for you, that may be different, and I'll leave it up to you how to create that JSON array. But for me, it's really easy here because this array is encodable. So I can create a new static property called data that is an optional data type, and then try to return the encoded JSON using the JSON encoder to encode our sample array. And by using try question mark, it means that if it fails, the data will be nil. So we'll have to check on that. Now, I'm a firm believer in asking permission to attach data because the user may or may not want to share that information. So I'm going to use the new iOS 14 confirmation dialog to ask that question when they tap on a button. If they decline, I'll just call the old method. Otherwise, I'll use this new view and we'll have to present that as a modal sheet. So the first thing I'll do is create a new state property that I'll call askForAttachment and initialize it as false. Next, I'll add the confirmation dialog method to the navigation view using the title, presented actions, and message initializer. Now the title isn't used in iOS, so I'll just pass in an empty string. IsPresented is bound to our askForAttachment. Then I'll hit enter on the action to create our two trailing closures. For the message, which is going to be shown at the top of the dialog, I'll use another multi-line text view, and on the first line in caps I'll type support email, and then on the second line I'll just write include data as attachment with a question mark. So that's our question. Well, our actions then will be two buttons. The first one will say yes, and the second one no. So if they decline, then the action for our no button is simply going to call that email send function passing in that OpenURL. It's the yes action then that we have to use our new mail view. So the first thing we'll have to do is assign the data to that instance. But we'll get an error message saying that it's immutable. No problem though. On that variable where we instantiate our property, we'll change it to a state property. In fact, this is exactly what we need anyway for our UIViewRepresentable. It has to be a state property. Now this view needs to be presented, so we'll need another state property to trigger this presentation. And I'll call it showMail, and I'll set it initially to false. Also, we're not sure if this device that we're on will be able to send mail. Now remember, our OpenURL contained a completion handler that helped us. This new mail function doesn't do that. However, the mail function will. And the first thing that we should check to see is whether or not our data is nil. If it is, we'll just use that old method. Else, here's where we can use the mail view's static property can send mail, and that will check if our app can send mail from the device that it's on. And if so, we'll toggle the show mail property. Otherwise then we'll use that print statement, but we'll have to make sure that we change the body to add the email instance. Finally then, all we need to do is to present the sheet along with our mail view, and this is bound to the presented state property. And we won't need the onDismiss function, just the trailing closure for our view. In the closure then, we'll present our mail view, which is bound to our email instance, and it provides us with a callback, which is a result type. And we can switch on our result. In the case of a success, I'll just print email sent. If perchance it fails, we'll get the failure case with an error, and I'll just print out the error's localized description. And we have one more thing that we need to do, and that's to change the toolbar action to set off the confirmation by toggling the askForAttachment property. If I test on the simulator now, no matter what, we'll get the console printout. Let me test on my phone now. First, let me check without an attachment. This calls the old method, and notice that I am now in the Mail app And when I cancel here, I'm still on the Mail app, and I have to back out to get back to my app. So let's try the Yes option that will include an attachment. Yes, that looks good. And now this time, notice that whether I cancel or send, which I'll do now, I'm taken right back to my app because it was just presented as a modal sheet. It didn't use the iPhone's Mail app. Anyway, let's check to see if I got an email. Yes, I did. And that attachment is there as expected. Now, I hope you learned something from this video and that you'll be able to use it in your own projects. Giving your users the ability to provide feedback, whether positive or negative, is really important. Thanks for watching.